Okay, these are long division problems cannot be squished into this space, but oh well. What I'm going to do is just give you all the answers. Some of you are like totally comfortable with long division. You just need to check that you haven't screwed up the subtraction. You can tell about the subtraction for these if it says it has no remainders. Then the value at the end is 0. So all the even numbered problems, the answer is 0. Alright. This is an if and only if statement, incidentally. So I'm just going to write 0 for all the even ones. And then for the odd ones, what I'm going to do is give you the answers. You can just check. And then if you need the details, I'll be writing it really small and zooming in. And if you don't need the details, skip ahead. Again, skip ahead unless you want to see the long divisions. I'm going to do them with small pen. So, to remind you, first you look at the x and the 5x cubed and you say x times what? 5 and x squared. And then you say, okay, now we have to multiply both things by 5x squared. So 5x squared times x is 5x cubed, but we also have to multiply 3. So 15x squared, line it up under the other x squared. We either put parentheses and a subtraction sign or just distribute minus signs and add. 2 minus 15 is negative 13. Bring down the rest of the junk. I mean the wonderful stuff. Okay, x times what to give you negative 13x squared? That'd be negative 13x. And then 3 times negative 13 is negative 39. Distribute the negative sign by switching, and negative 45 plus 39 is negative 6 x's. And x times what? Negative 6. So, and then 3 times negative 6 is negative 18. Again, distribute the minus, the subtraction, and sure enough, it adds up to 0. Next. Okay, x times x squared to give you x cubed. Distribute the x squared to both of the things on the outside. Distribute subtraction by changing signs and add. X times what to give you 5x squared? That'd be 5x. Distribute to the minus 6 also. And change the signs and add. X times negative 14 is 6 times 14, 84? Yes, it is. Haha. Negative 6 times negative 14 is also 84. Change the signs and add, and you get a remainder of 0. Next one. Oh, look, they both cancel. Distribute subtraction, and just bring down the 12x minus 60, and x times 12. And is negative 5 times 12 negative 60? Sure it is. Distribute the subtraction by changing the signs, and add. And you have a remainder of 0 again. What a surprise. Alright. Next one. Oops. That's tedious. Okay, let me just get these down. Oops, I lost the x. Look at that. Okay. Alright, x cubed times x plus 2, and then distribute the subtraction. 6 minus 2 is 4. Let's see, 2 times 4x squared is 8x squared. Distribute the subtraction. I sometimes write the minus 1 down, even though you don't need to write the 1. Just, you know, why not? Okay, 2 times 9x is minus 2x. Distribute the subtraction and add. Negative 6 plus 2 is negative 4. Okay. And have we got it? Yes, we do. Okay, so distributing the subtraction, we get 0. All right, going on to the next stuff, because that's just really annoying. Predict the number of roots. Okay, the fundamental theorem of algebra says, let me just say this, and then I'll actually I'll do the problems up. Oops. Okay, so the fundamental theorem says the degree is the number of roots. So let's predict 2, 3, 1, 4, 2, 6. Those are the highest exponents. Some notes on each of these. The note for this one, this has 2 real roots. It doesn't have any complex roots, or at least not imaginary, because A, it can be factored, and B, if you do the quadratic formula, b squared minus 4ac, 9 minus 4 times negative 10 is positive. This one, and I will do it down below when they're actually going to do the graphs, but this one, if you break it into 2 chunks like this, you can factor out common factors and see how to break it down. Same thing with this one, although you can factor out an x first or afterwards. This one will factor out a negative 1 first. because people really screw up if they try and do unfoiling with a negative x. People mess up the signs. This one we can factor also, and again I will do it down below. Okay, so this one, the predicted roots is 2 roots. What are the roots? Okay, so let's do it for this simple one. We'll factor x squared plus 3x minus 10. X and x. Then you look at the 10, that's 2 and 5. To get positive 3, I need a positive 5 and a negative 2. And sure enough, so x minus 2 equals 0. I'm only going to do this the slowly once. But here are my 2 roots. On the x-axis, which I will just highlight for you here. Oops, that didn't work. Okay. The 2 roots are here and here. So the roots are x-intercepts. Now you can write the x-intercept as points or as just x values. There doesn't seem to be a consistency in the textbooks about that. Okay, so the factored form is x minus 2 times x plus 5, which we could have done roots first. Next one. Okay, where is the x-axis? There it is. That looks like negative 3. Negative 1 and 3. And so x minus negative 3, x minus negative 1. Remember, it's opposite for x's. Okay. Okay, I'm going to take 2 chunks and factor the x squared out of the first 2 pieces and the negative 9 out of the last. This doesn't work unless the function is specifically designed to work, but since these are both x plus 1s, we can factor them out as a common factor. And then break down x squared minus 9. Okay. Next, the only root is at negative 2. Factored form is negative 2x plus 2. This is not the root. This is just a coincidence, which they should not have put in there. Okay, so notice a linear function always just has one real root. Okay. Next, the picture's on the next page. How annoying. I'm going to write it before I lose it. factor out. So let's see if we can find this. 1, 1, 1, 1. Okay. Okay, so the factored form should just be x plus 2, x plus x minus 0? Let's think about that for a minute. I'm going to write it that way for a minute. Okay, so from an algebra point of view, let me just show you how that works. Okay, so I'm going to break the inside up. X cubed minus x squared is x squared times x minus 1. And then I'm going to factor out negative 4. And again, negative 4 times what to give you positive 4? Oh good, it's another x minus 1. Okay, I no longer need the extra parentheses, so I'm just going to hook them. And that's going to end up being, that's the x minus 0. Okay. So for this one, it's only got a single root at 3. What do you do? It's got to have 2 roots. Huh. Let's try the algebra. Ah, x squared minus 6x plus 9 does factor nicely. Okay. Oh, so the root is a double root. And we can tell it's going to be a double root because it bounces off the x-axis. All right. Next one, let me write that down. X to the 6th minus 5x to the 4th plus 4x squared. It should have 6 roots. 1, 2, 3, 4, 5. Where's the 6th one? Oh, it's a double root at 0. Okay, so how can I tell it's a double root? Because it bounced. And let's just do the algebra. You can factor x to the 4ths with x squareds the same way you do regular ones. You just have to have x squareds. Let's see. 4 is 4 and 1 or 2 and 2, and we can tell it's 4 and 1 because of the 5 in the middle, so, and 2 minus signs. Okay, and just so for a note, to say again what we've been saying. Okay. Find the roots of a quadratic function. Here's a nice stupid number. 51. 51 is 17 times 3. Oh, then it's easy to factor. Okay, don't forget to do opposite for x. This factors also. Okay, next. Factor out of 3x. There's two roots, don't forget. X equals 0. How do you factor x squared minus 11? Well, x squared equals 11 when x is plus or minus root 11. So okay, this one does not factor. This one needs to be graphed or the quadratic formula. I can't write anymore. Okay. Gonna do the quadratic formula. Let's just write down the quadratic formula. Okay, a is the number that goes with x squared, b is the number goes with x, and c is the constant term. If this equals 0, then x is opposite of b, plus or minus square root b squared minus 4ac. Watch that when c is negative, that ends up being addition. Sorry. Just made a bonking noise. Okay. So let's just do this one with the quadratic formula. Opposite of 1, so 1, negative 1, opposite. 1 squared minus 4 times 1 times negative 1, all over 2a. Okay, just to remind you, this is two separate answers. 1 plus root 5 all over 2, which is 1.618-ish, and 1 minus root 5 over 2, which is uh, negative 0.618. Okay, this next one I can't graph because it doesn't hit the x-axis. So we have to do the quadratic formula. It's going to have imaginary roots, so expect that. There's the imaginary because oops, let me fix that, it's horrible. The square root of negative 8, so I'm going to factor out square root of negative 1 and the perfect square. And I'm going to rewrite it as 2I root 2, or I times 2 root 2. Okay, now notice the only factors we can cancel are the 2's that are on the outside, and we can only cancel if we can cancel it from every term. So final answer, negative 1 plus I root 2 and negative 1 minus I